In this unit, we'll be looking at angles and parallel lines. This lesson is about applications using angles. All right, hi everybody. So in this lesson, we're going to be looking at angle applications, because there are actually lots of places where people are going to think about and use angles. Okay, it could be work or hobbies, for example. And some common applications include true bearing. So when we talk about true bearing, it's like you're looking for directions. You're going to identify kind of what direction something is located from a given spot, and we'll talk about that. Okay, so using a compass here, obviously angles become important, but they're important in carpentry too. When you're trying to kind of build something, I'm sure you can think of all sorts of applications. Even if you just look around your house, where you'll notice that wood has been cut at certain angles in order for it to fit in certain ways. If you're like when you look at a window, the frame around the window, if you look at the corners there, you might see miter cuts there to have the corners form nice 90-degree angles. When you're going down a staircase, you might notice some of the angles cut into the wood to make the staircase just gentle enough that it's not awkward to go down. In any case, let's go back to talking about true bearing here. True bearing to a point is the angle measured in degrees in a clockwise direction. Okay, so remember, clockwise we're going this way. Okay, the same direction as the clock. From the north line. So north is going to be like our zero spot there, and then we start to measure angles from there all the way around. Okay, and just take a look at the way this works here. So now, on an exam, you would need to draw out this compass for yourself here. It won't be provided, so just as long as you pay attention to that here. But notice how that works here. Okay, so each of these angles here that you're seeing, we're going to measure from north, and we're going to go clockwise, and we keep going all the way around there. Now, up here you're going to see 360, but you're also going to see 0, 0, 0 with the degree symbol. It's common to express bearing with 3 digits, just to avoid confusion. Okay, and yeah, so anyway, so for example, if someone said 45-degree bearing here, and they were giving that to somebody, they might say 045 degrees. And the reason why that avoids confusion here is because if all you heard was 45, you might think that you maybe missed a number in front, like 145 or 245 or even 345 degrees. You might have missed that first number there and just been hearing the last two. So by giving all 3 digits there, it just helps to alleviate some confusion that might pop up. At least that's a common way that gets done here. For a lot of what we're going to do here, it's really not necessary for us to follow that all that closely here. Anyway, let's take a look at some questions here. All right, our first question says, when using a compass, we measure directions from straight north clockwise. We were just talking about that. What would east, south, and west be? Okay, well, fortunately, we actually have the compass right up here. And so what would east be? Well, east is going to go this way. That is going to be 90 degrees. So east is at 90 degrees, or we might write this as 090 degrees. Okay. South, look at south here. South is pointing straight down. It's the exact opposite direction from north here. So that's going to be 180 degrees. Okay, and west. Well, west goes all the way around. It's 3/4 of the way around from north going clockwise, and that is 270 degrees. Okay, so east, south, and west in terms of their bearing. Now, if Jess was facing south and turned 45 degrees to the right, now we got to think about that. She's facing south. So you got to put yourself in that position facing this way. If you were to turn to the right, that is going to be this direction here, 45 degrees. What direction would she be facing? Okay, well, this is going to be, south is 180 degrees, and if she turns 45 to the right, that's going to add, because remember, anytime we're going clockwise here, we're going to add to this. It's going to get bigger here. We're going to add 45 degrees to that. And that is going to get us 225 degrees. So she's going to be facing along a bearing of 225. Now, interestingly though, if let's draw this out again here, and we'll draw out the whole thing. So if she's facing south and rotates 45 degrees to the right, okay, remember that the angle between south and west is going to be 90 degrees. And so if this is 45 degrees in here, then she is facing directly midway between south and west. And we would also call that southwest. If you go back to our compass here, you're going to see that southwest, and it's 225 degrees. Okay, let's take a look at some other questions. Okay, if Jess was facing southwest, so that's where we left off, and turned 90 degrees to the left. Okay, so now 90 degrees to the left. So here we are. We're going to draw that compass out again. So she was facing this way. And now remember, she's facing this way. So if she turns to the left, it's going to be this way. Okay, and then 135 degrees to the right. Okay. So she's going to face 90 degrees this way. And then she's going to turn 135 degrees to the right. So now, remember, all the way back there would be 180. So it's going to be a little bit less than 180. So that's the final position right there. So let's just figure out what's going on here. So she was facing southwest. So that's 225 degrees. We just saw that. Turning to the left is going to be turning counterclockwise. So what's going to happen here is we're going to subtract that 90 degrees. Okay? Because turning clockwise is going to add to the angle. Turning counterclockwise, we're going to subtract. So turning 90 degrees pushes us back towards north, the other way that we came here. But then we're going to add 135 degrees to the right, which is going to be clockwise. So then we add 135 degrees to that. Okay, now, when I do that, and I did that on my calculator over here, I get 270 degrees. Or west. 270 degrees is 3/4 of the way around the circle, so that's going to be west. So my diagram was wrong. Okay, I'm just drawing it out here. You don't know until you do it here. So what actually happened here is she was facing this way. She rotated 90 degrees so that she was facing this way. And that, by the way, rotating 90 degrees from there is going to put her at southeast. And then 135 degrees put her facing west. That's what actually happened. This actually is not the way that worked. Okay, now let's look at another type of an application here. Sierra is installing a window that opens such as the one on the right here. Okay, so you can see how they're pivoting out here. Here's where the hinges are, so they're kind of pivoting out like that. The window has 3 settings, 30 degrees, 45 degrees, and 60 degrees from closed. And the window opens outward. So at each of these settings, what is the angle that the outer wall makes with the open window? Okay, so let's just take a look at this. So here's our wall here, and let's say our window's here and it's opened up. We're going to do it the first setting here. So if we know that this is 30 degrees, the question is, what angle does it make with the wall? Now, if we think back on a previous lesson here, we're going to notice that these two angles here, the angle that we're given, this 30 degrees, and the angle that we're looking for here, these are going to be supplementary. In fact, for each one of these things, that's what we're asking for, the supplementary angle. And so remember how we do that. On our calculator, if we're going to come up with a supplementary angle, we're going to type in here 180 minus the given angle. And so in this case right here, 180 degrees minus 30 degrees is equal to 150 degrees. That's the angle with the wall. Okay, so for our next one, okay, window is open a little bit more. This time this is 45 degrees. And again, we're looking for supplementary angles, so it's going to be 180 minus 45 degrees, and the answer is going to be 135 degrees. So this angle right here that we're looking for is 135 degrees. Then we've got that last setting, and this time the window is open even a little bit more. Okay, this is our 60-degree angle here, and we are looking for this one right here, which will be 180 degrees minus the 60 degrees, or 120 degrees. Okay, so there you go. And notice that as this angle, as the setting angle that our window is at gets larger, the supplementary angle here, okay, or the other angle that we're looking for, got smaller in every case. Okay, here we go. A miter joint used in carpentry is two pieces of wood to be joined to make a right angle, each cut to bisect the right angle. Now remember what that means. Bisect means we're cutting it in half. Okay, exactly in half, that right angle. So the right angle is 90 degrees. Okay, so first of all, to sketch the scenario below it, now it's kind of odd here, but we do have a sketch here. Basically what's happening is we've got this 90-degree angle right here. Now you can do this a couple of different ways. Okay, one way that you could do that is you could put the two pieces of wood together like this, right? Okay, totally you could do that. As long as this is cut straight, like 90 degrees to the side of the wood here, that would work fine. But maybe you want something to look a little bit different here. And so what we're going to do here is we're going to cut these two pieces of wood so that when we put them together, okay, maybe glue them together or we fasten them together with nails or however we're going to do it, that we get a 90-degree angle there total. Now, what is the measure of the angle each piece of the wood is cut at? So in other words, we're asking, what are these angles right here? Well, remember, this is a bisector. So we're going to take 90 degrees and we're going to divide that by 2. And we get that the angle that we're cutting this at is going to be 100. Sorry, I was going to give you the supplementary one of that. It's 45 degrees. Now, here we go. What if Caleb accidentally cuts one of the pieces at an angle of 43 degrees? At what angle does he need to cut the other piece to still produce a right angle? So he can still do this. But what's going to happen here is it's not going to look quite right here, but we can still do it here. Now, we are looking for the complement, okay, to that particular angle here. So that'll be 90 degrees minus 43 degrees, and that's going to equal 47 degrees. So he's going to have to cut one at 47 degrees. Now, what ends up happening in a situation like that, though, because the angles aren't 45, then what you get is a scenario that looks a little bit like this. Sorry, it's going to look a little bit, probably more like that, where the pieces won't exactly fit together. And there's going to be this odd little connection right there. It'll be somewhat obvious. Now, at a 2-degree difference, maybe not such a big deal. Maybe small enough that you won't see it here. But yeah, the more one of these angles is off and the other one has to kind of adjust to compensate, the more obvious it is that it's hasn't been bisected. Just something to think about.